Is to talk about decision trees, entropy, information gain and gain ratio in decision trees as part of the machine learning or information theory, whatever you call it. So I want to talk about three things. One, entropy. Two, information gain. Three, gain ratio. This will help us in building the decision tree and deciding what is the best splitting attribute to use in a certain level, which attribute to use to separate the tree. Genie is another way to do it. I'm not talking about Genie now, I talked about it in another video. So the idea is if you are in decision tree and you are in certain level and you can split this level with the very different attributes, like I can decide that I can split now. If I am now in the decision tree, I am in a certain node, and now I can split by, I don't know, attribute b is greater than 2. This is the attribute I use, and this is how I divide the data. If I have an attribute, what is the weather today, sunny, rainy, so I can divide by this. I need to know, and I have another attribute, what is the temperature today, hot, cold, and etc. So I need to know which attribute to take to split the data, which is the best. The temperature, the humidity, the weather, maybe another thing, which is the best attribute to split now. And the idea is this, to use entropy. Entropy comes from physics, from thermodynamics. The idea of entropy is a value that represent impurity, that represent a orderness or unorderedness. Um, and as the entropy gets higher, the impurity of the data is higher. There is more mess, there is more confusion in the data. As the entropy is lower, there is more order, there is more homogeneity, there is more purity in the data. Therefore, if I split the data, if I take an attribute, they split the data very good. In one group, there is only from attribute 1, and the other group only from attribute B, and the other group only from attribute C, and etc. and etc. This is the best splitting, and the entropy will be the best, will be the minimum entropy, 0. Um, but if I have a splitting that is very not homogeneous, very impurity, namely when I use this attribute to split, I get in the first sum of A, sum of B, sum of C, even the worst case, the same number from A, the same number from B, the same number from C in the same group. And again, in the second one, I get the same. The same number from A, the same number from B, the same number from C, and etc. etc. Namely, the splitting didn't help me at all to differentiate between the data. This is the worst uh, splitting and will have the highest entropy. So the entropy can tell me how there is impurity, how much there is disorder, how much there is impurity. So I will use this. What I will do to know if the splitting is good, what I will do is this. I will calculate the entropy of my data now. This is the formula for entropy. We will talk about it. I will calculate the entropy of the data now, and I will calculate the entropy of the data after the splitting. The difference between the entropy before the splitting and after the splitting, this will be called the information gain of splitting the data D by using for the splitting the attribute A. So I take the entropy of the data and reduce the entropy where it is. Reduce the entropy of the data after splitting. This will say to me how much I gained information, how the splitting helped me to differentiate the data. Because as the data gets more organized and more distributed and more homogeneous in each group after the splitting, so the difference will be higher. So the information gain will be higher. That means that if the splitting is good, the information gain will be good. And I will choose the attribute that will cause the highest information gain from the splitting. There is a little problem, that there is a little bias in this formula for attributes with a lot of data in it. So what we can use to eliminate this bias is use what is called gain ratio, which is take the information gain you just got and divide it by the entropy of the attribute you used to split the data, where the entropy of the attribute you use to split the data is, we'll see how we do that, is based on the number of instances there are in the attribute. So for example, let's do a calculation for entropy. Look at the formula again. The formula for entropy of a data set is the sum minus the sum of the probability for type A in the data times the log on base 2 of this probability for these instances, for this class. Okay, you are taking this and you sum it up, you will get a negative number. This is why you are doing here a minus, because log 2 of a probability between 0 and 1 will be a negative number. Think about it. Log 2 says 2 to the number of what, to the power of what, will give you a number between 0 and 1. It will be a negative number. Therefore, you will sum up negative numbers. So giving the minus here before will give you a positive number, and we want to work with a positive number. So let's try to do a calculation, an example. So I have a data set with 10 instances. 6 of them belongs to the class of yes, and 4 belongs to the class of no. What is the entropy? So firstly, we need to calculate the probability of each class. So the probability of class yes, 6 out of 10 is this. The probability of class of no is 4 out of 10, which is this. Now, the entropy is again minus, remember, minus sum the probability of class I times log to the base of 2 of the probability of class I. Probability times log 2 probability, sum and minus. So here we do that. The probability of class 1 times log 2 probability of class 1 plus, this is a sum, probability of class B times log to the base of 2 probability of class B. We are summing it up and then we take the minus. This is the entropy for this data set with the two classes. Now I'll calculate it and get a entropy value. Now it's not 0. It means that it's hard to differentiate between the two because they are almost the same number from each. If it was like 10 instances of yes and 0 instances of no, so we would get the best entropy, namely 0, because it's totally purity, totally ordered. But now almost half and a half, almost 50-50 for the two instances, so it's quite high entropy. Now let's look at information gain. Information gain needs, we answer using this information gain the question, which attribute is better for the splitting? So assume we have an attribute A. We used it to split the data. I don't know, like split the data using what is the weather. Days that, I don't know, if this is a data of days, so days that are warm days that are cold, days that are, I don't know. So let's call the attribute, let's temperature A, and we split the data based on this attribute. For example, temperature. And the values from this for this attribute is A1 and A2, like cold and hot. So when we split, we'll split the data and part of it will be hot days, let's call it DA1, and part of it will be cold days, day 2. Now the target is, I don't know, to know in which days there are good news, okay? So uh, 3 out of 5 uh, days of the cold days, I don't know, are good days, are and 2 out of 5 are bad days. In the cold weather, 3 out of 5 again are good days and 2 out of 5 are bad days. We get the same value for each, and this means that it didn't help us at all. Uh, no, it doesn't mean that it didn't help us at all. This tells us they didn't help us at all. Now, the information gain is taking the weighted sum of both entropies and taking the entropy of the father of before the split and take the difference and calculating. And because the difference is zero, this tells us that the splitting didn't help us at all. Sorry for saying that if they are the same, it said that it didn't help us. It doesn't. The information gain tell us if the splitting was helping us or not. If the information gain is zero, it said that we didn't learn anything from the split. But if the information gain is not zero, we did learn something. We did make a better splitting. We did the splitting helped us differentiate the data. But here the splitting didn't. Now for gain ratio, we are calculating the information gain and calculating the entropy of, I don't know if we call it entropy. Entropy is not a very good word to tell. Yes, it call it entropy. Entropy of the attribute. Okay. So you calculate this. This is use the instances of the, yes, the attribute, and you get attribute with entropy of 1. So you take the gain ratio, which is information gain divided by the entropy of the attribute, and you get the information gain divided by 1. This is not the best example for the numbers, but okay. Let's look at a more concrete and more interesting example. So this will be the example as you can see here. So I have data. The data have attributes. Those are the 4 attributes: outlook sunny, overcast and rain, temperature hot, mild and cool, humidity high normal, wind weak strong. And the dark target class will be play tennis yes or no. Namely, I need to know what is the probability of each instance, right, in the calculation of the entropy. But probability to why? To what? Target class tell me what to probability of what? Probability to play tennis in this case, yes or no. So for each instance, I know what is the probability to play tennis, yes or no, and I want to use the decision tree to divide the data such that I will know for each person based on the attributes if what is the probability if he would play tennis or not. Let's say if he will play key, because the decision tree will decide in the end if he will play tennis or not. So let's see how it works. So the first question is how to divide the data. I have the data now. Let's divide it by the outlook. Let's divide the people by the outlook. Sunny, overcast, rain based on the day, or let's divide the data by temperature, or let's divide it by humidity or wind. Which attribute is best to use to divide the data? Think about the tree. Which is the best to use to divide the data? And you can see how it goes. I have the data and I will divide it by the outlook. Firstly, but how did I know that I need to divide it by the outlook? I use the entropy, the information gain and the gain ratio. So I start with calculating the entropy of the data. And we assume there are 14 instances, 9 of them are yes and 5 are no. And let's calculate the entropy. The entropy is minus the sum of the probability for attribute 1 in the data itself, it's 9 out of 14, plus a times log 2 to this probability, plus 5 out of 14, this is the probability to get no in the full data, times log 2 to this probability. Sum it up, you will get a negative number, so take the minus, and we'll get a positive number that present what is the entropy of the data itself, the whole data. Okay? So now we will check for each attribute if we use this attribute, this, or this, for splitting, which attribute will give us the best splitting, namely the highest information gain, or more precisely, the best gain ratio. Namely, which split will get the data as more organized as possible, less heterogeneous as possible, more homogeneous as possible in each class it creates. So let's start with Outlook, which has sunny, overcast, and rain. So if I divide the if I divide data by Outlook, I will get subsets. Subset 1 will have sunny, and we tell you in this example that 2 of the, I don't know, days that are sunny, the answer is yes, and 3 are no. If they also overcast, 4 is yes, 4 are yes, and 0 are no. This is very good, and because this is very dichotomic, yes totally, no totally, it will have very low entropy. As you can see, the entropy for overcast is 0. This is because the very purity, the distinction between yes and no is very good. And rain will have 3 with yes and 2 with no. So let's calculate the entropy of each subset. Let's start with sunny. What is the probability for yes? 2 out of the total. 2 plus 3 is 5. 2 out of 5. Log 2 to this probability plus 3 out of 5, this is the probability for no. 3 out of 5 log 2 to this probability minus, and we got the entropy for this subset. Now for the subset of overcast. 4 out of 4 for yes, 0 out of 4 for no. We take the values, plug it in the function, and we get 0. This is because it's very dichotomic. We have only yes without no's. This is why the entropy is so low. It's very good, and this is why it's 0. Now for the last one, it's raining. So 3 for yes, 3 out of 5, 3 out of 5 log 2 of this probability, plus 2 out of 5, and take the minus, and this is the entropy for rain. So now we need to calculate the gain ratio, the information gain. So the information gain for using the attribute outlook for dividing, for splitting the data from the first, taking all the data and split it using outlook will give us what? The entropy of all the data is HD, so it will be here, it's this value, minus the entropy after splitting. And what is the entropy after splitting? Take the weighted sum. In Sunny, there are 5 instances out of how many total instances? There are 14 total instances. So 5 out of 40 are in the Sunny. So 5 out of 40 multiplied by this probability, plus how many are there here? 4 out of 40 for overcast, 4 out of 40 for the entropy of the overcast, and how many for this? Again, 5 out of 40, so 5 out of 40 for the rain, add them up, make the weighted sum for this entropy after splitting using Outlook, take the entropy of the data before splitting, reduce from it the entropy of the data, the weighted sum of the entropy of the data after splitting. This will give you the information gain for the attribute you used for splitting for Outlook. So calculating this, we get the value 0.246. Now doing the same, okay, so this is the information gain for dividing the data, for splitting the data using Outlook. Now we will do the same with the other attributes, and we will see what is the information gain we will get by dividing the data using the other attributes. The attribute that will give me the highest information gain, the highest information gain, not the lowest, will be the best attribute and will be the attribute that will be chosen for splitting the data. Now, to be more precise, I will do information gain ratio just to make sure that we are dealing with the bias of the of attributes with a lot of data. So for in the end, we will take the gain ratio, but again, it's the same idea. Take the gain ratio, which give you the highest value. So let's do the same like we did here with temperature. So with temperature, we are dividing the data to desk groups, hot, mild, and cool. And in hot, there are 2 and 2. This is very bad for entropy. This is not helping me differentiate between yes and 2. The entropy will be very high. Mild, which will have these values, and cool. So we will calculate entropy, and we are calculating because there is no differentiating 2 and 2, they are the same number, so the entropy will be 1. You can calculate it 2 divided by 2 times log 2 to 2 by 2, so it will be 2 to 4, sorry, half time log 2 of half plus half time log 2 of half, and it will be just 1, entropy of 1. So the entropy for the other ones, so for this you take the probability for yes, 4 over 6, probability for no, 2 over 6, calculate the entropy, do the same for cool, 3 out of 4, 1 out of 4, and calculate entropy for each one, then take the weighted sum and calculate the information gain. The information gain for splitting using the attribute of temperature is the entropy of the data before splitting again, minus the weighted sum. Here there are 4 out of 40. Oh, here there are 6 out of 40. Here there are 4 out of 40. 4, 6, 4 out of 40, 40, 40. So this take the weighted sum, reduce the weighted sum from the entropy of the before splitting. This is the information gain. You can divide it by the entropy of the attribute. We will do that, I think. I think we'll do that, yeah. You will divide it by the entropy of the temperature. Look here, we are just taking 4 for hot, 6 for intermediate or mild, and 4 for cold. Note how it differs from the entropies here. Here we are dividing inside the attributes to yes or no. Here in the temperature entropy, we are just taking the amount for each subset, amount of instances in each subset. We don't differentiate between yes and no for this entropy of the temperature. So we will do it later. Okay, so this is an information gain for temperature. We will do the gain ratio later. Humidity, we are doing the same subset high, normal. We are calculating the entropy for each subset, for each class. We get the entropies. We are calculating the information gain for humidity, the entropy of the data itself before the splitting minus the entropy for the data after the splitting. This is the information gain. Which is the best? Look at the information gains. It looks like the highest value for the information gain is here of the outlook. Temperature is lower, humidity is lower, so it seems that outlook is the best way to split because it has the highest information gain. Namely, the splitting using outlook will give me the best subsets with as best as I can homogeneity in each subset. I will be able to differentiate better using this splitting in comparison to the other attributes, other splittings based on other attributes. But now I just need to correct this using the gain ratio. Oh, we forgot the wind. When we are doing the same uh, subsets split by the wind, weak, strong, take information, take entropy for each subset, calculate the information gain. This is the information gain. Okay, so now let's do gain ratio. We are calculating the entropy of outlook. Now, don't be confused by how to calculate entropy of an attribute. Here, you are not looking at yes or no of the subset. You are just looking in each subset, how many instances are there? How many instances are there? You don't care about yes, no, what happens to these instances. You're just taking how many instances in each subset in Outlook. There are five, I don't know, five in sunny, four total in overcast, and five in rain. And you use this. You don't use 2 out of 5 or 4 out of 4 or 3 out of 5. You're using 5 out of the total, 4 out of the total, and for rain, 5 out of the total to calculate the entropy of the whole attribute. Here, we took the entropy of the subsets of the attribute, okay? But now we are calculating the entropy of the whole attribute. So it's for rain, it's 5 out of 14. For the intermediate, I don't remember what's name, 4 out of 14. And for whatever rain is 5 out of 14. So this is the entropy of the whole attribute. And we are correcting the information gain and dividing the information gain we got from Outlook, information gain, and we divide it by the entropy of the attribute. As bigger the information, the entropy of the attribute, the lower the gain ratio will be. So high entropy attributes will let's say make the gain ratio lower. So the gain ratio for attribute outlook is this: information gain divided by the entropy of the attribute. This is the gain ratio we got for the attribute outlook. Now we're doing the same for temperature, calculating the entropy of the temperature. This is the result. This is the gain ratio. Again, information gain of temperature divided by entropy of temperature as a whole, not a subset of temperature, as a whole. Doing the same for humidity, gain ratio this. Doing the same for wind, the gain ratio is this. Now, which attribute, after all this calculation, which attribute we would use to split the data? The answer: look for the highest gain ratio. So we're looking at the gain ratios, and we see that the highest gain ratio is again for Outlook. It could have been that after calculating gain ratio, we would get another other attribute which would be better, but in this instance, in this example, we got that the gain ratio, the highest gain ratio, is also the attribute with the highest information gain, but it doesn't have to happen. It doesn't have to be like that. In this example, it did, and the gain ratio of Outlook is the highest, and the information gain of Outlook is the highest. So we'll choose the Outlook as the splitting attribute now. After this, in the next steps, we can choose other attributes. Again, in the next step, now we will split the data based on Outlook. We will split it, and note that will be again. We don't have an answer for the nodes, namely nodes that part of them are yes and part of them are no. We will need to continue split. We will choose in the same way, with the same idea, another attribute for splitting, but note that will become very purity, namely with entropy of 0, like we had here. So the overcast will be halted. We will have an answer to all the instances that will get to overcast. We will have an answer. The answer is yes. Okay, and for the sunny and for the rain, because still there are part of them is yes, part of them is no, we will need to continue splitting, and we will choose which attribute to use to continue splitting based on the same idea. We will calculate, we will know what is the entropy of the data here, and we will split it with each of the attribute. For each splitting, we will check what is the entropy of the a node that will be created by the splitting. We'll take weighted sum, we will calculate information gain, gain ratio, and this will be for each attribute, and the attribute with the highest gain ratio will be chosen to split the rain. The same thing we will do for sunny. For overcast, we don't need because there is no need to split it anymore. We have an answer. The answer is yes for whoever gets to overcast. Okay, so this is the idea of the decision tree we will get. The first split will be, as we saw, using outlook, sunny, overcast, and rain. Overcast will have entropy of 0. All of them are yes. So in our decision tree, we will say that whoever gets to overcast, we will classify it as yes. For sunny and rain, we didn't get an answer yet, so we need to continue splitting. We can use a we can check which attribute is best to use to split it. So here, if we would continue the calculation, maybe we will choose humidity. Maybe this will have the best gain ratio for dividing sunny, and therefore we'll get high and normal, and then we get an answer, so we stop. For rain, maybe wind would be the best. Again, we need to calculate it, but let's say this is the attribute that will have the highest gain ratio. So if this is the way it goes, so we have weak and strong. For each of them, there will be an answer. And here we get a tree. Now, this tree was built using the training data. And again, of course, using the test set or the real data, maybe we'll we won't get complete 100% right, but this is our tree. This is how we will uh, classify the new data. We will say, okay, new data, start with outlook. Are you sunny, overcast, or rain? If you are overcast, I will say yes. You are going to play golf or whatever the target is, because this is yes. If you are sunny, look at the humidity. If the humidity is high, so no, you are not going to play. If the humidity is normal, yes. Okay, if you are rain, look at the wind. If it's weak, yes. If it's strong, so no, you're not going to play, or whatever the target was, play tennis. So you can see how we built a tree that we can use on real data to classify it based on what we want to know on the data. In this case, you want to know if he's going to play tennis based on the attribute that we used. Maybe other attributed are better, but from the attributed we checked with the data we had, this is the best tree using entropy, information gain, and gain ratio. Thank you very much. Let's look at the for the last time. Let's look at the formulas for the entropy. This one with the probability is log to probability sum minus. For information gain, we have the data in attribute, and we take the entropy of the data minus the, let's say, the weighted sum of the entropies of the subsets of the attributes. This is for information gain. And for gain ratio, you take the information gain, divide it by the entropy of not the subsets of the attribute, of the whole attribute. And don't confuse between this and this. Okay? So this is the gain ratio, higher gain ratio, better splitting, and we will choose the attribute with the highest gain ratio for splitting. Thank you very much. This was about decision trees and how to build them using entropy, information gain, and gain ratio. Thank you for this speak for building the formulas and everything. If there are any mistakes, please correct me. And if I made mistakes, I'm sorry. I wish it was a little bit of use and help you to understand decision trees in information theory, machine learning, entropy, information gain, and gain ratio.